Hello everybody, welcome to the Carl and Cymru revision sessions. The session this evening will focus on GCSE mathematics, will be presented by Mrs Claire Dixon from Pentre Harbour School in Swansea. The session will last around 45 minutes, where Mrs Dixon will run through the relevant content. If you have any questions during the session, please use the question and answer section and we'll do our best to answer you. Before the end of the session, there'll be a hyperlink in the question and answer section. If you're happy to leave your name and email address, we'd love to keep in touch with you so we can send you some information about future events. You can click on the link at any time during the session. Today's session will be recorded, and the recording and any relevant resources will be uploaded to the e-sgol website under the Carl and Cymru tab. Thank you. Mrs Dixon, over to you.
Thank you, Mr. Casey. Okay, so this is our final session of this sort of term. We started last week with the probability trees, and we're going to continue with our probability theme now, and we're looking at conditional probability. So start with, okay, we're going to do a very quick recap of the work that we started last lesson, and these are the skills that you need. Okay, so can you pause the video and have a go at those questions for me? So we're going to go over them. And the first one, if you remember last week, okay, to multiply fractions, we're multiplying our numerators together, which is 10, and then multiplying our denominators, so 54. Now, I haven't said to simplify, okay, so you could if you wanted to, but you would get your marks if you didn't simplify in that one because the question didn't tell you to. If you did simplify, you would have had 5/27 for your answer there. Okay, when it comes to number 2, you can't just add your fractions if your denominators are different. So first fraction on the left, then I'm going to multiply by 8. And the one on the right, I'm going to multiply by 5 to give us some equivalent fractions that are going to have the same denominators as each other. So 8 multiplied by 2, 16. 8 multiplied by 5 is 40. And then on the right-hand side, then 3 multiplied by 5, 15. And 8 5s are 40 for the denominator. Okay, now the denominators are the same. You can just add your numerators together. So 16 add 15 is 31. Do not add the denominators, that is still out of 40. Okay, so check your answer there. We also need to do our multiplying decimals. So last time we did them by times in by 10 to get rid of our decimals, doing the whole numbers. So 2 multiplied by 4 is 8. And then we reverse the process of those times in by 10 for the left-hand one and the right-hand one. So you're going to have to divide by 10 twice or divide by 100 there. So 2 multiplied by 4 is 8, divide by 10, and then divide by 10 again, 0.08. And then the final one there, similar process to above, but the left-hand one you'll be multiplying by 100 because you've got 2 digits after your decimal. Right-hand one you're multiplying by 10. Then you're working out what 32 multiplied by 3 is, so that's 96. And then you need to reverse your times in and divide in there. So divide by 10 and divide by 100, and you will end up with 0.096 for that. Okay, so those are some of the skills you're going to need to make sure you are up to speed with those. Okay, the last session, we also did some tree diagrams. And again, we're going to need these in today's session. So I'm going to do a quick recap of this. So if you'd like to try it yourself first, please pause the video. If you're happy to just work through it with me, then we'll go ahead there. Caris has a Monday to Friday job and a weekend job. Working Monday to Friday and working weekends are independent events. And if you think back to last time, independent meant that they didn't affect each other. Okay, so working Monday to Friday does not affect whether she works on the weekend. In any given week, the probability that Caris works every day from Monday to Friday is 0.65. And that is on our tree diagram already. And then we're going to use that then to fill in the no that she doesn't work every day. And if we carry on reading, the probability that she works on both days during the weekend is 0.2. Okay, and again, that is on our diagram. So if we now look at the tree diagram part, if you think back to last session, we are adding up to 1 for each section. So 0.65 and something adds up to 1, so that missing number is 0.35. On the right-hand side, you've got 0.2, which means that for no, you'll have 0.8, and then because these are all independent, those will then repeat on the second section down there as well. Okay, first 2 marks are done. And now we want to calculate the probability that next week, Caris will work every day from Monday to Friday, to Monday to Sunday. So in other words, that's every day from Monday to Friday. So that's a yes. And then both days on the weekend. So we're going to carry on that path and we're following that up. Okay, so those are the numbers we're going to use. And we always multiply along these branches. So 0.65 multiplied by 0.2, and this is where your times and your decimals comes in. 65 times 2 is 130, and then you're dividing by 100 and then by 10 again. So 0.13 for your answer there. Okay. And the other style of question we did was this. So if you want to pause the video and try that before me, and then from there on, then everything will be the new section for today. Okay, so Tara has 8 balls in a box. 5 of the balls are blue, 3 are red. Tara takes at random a ball from the box and writes down its colour. Tara puts the ball back in the box, and that's really key. Okay, by putting it back in the box, it's not affecting the next one. So in other words, these are independent events. So then Tara takes a random a second ball from the box and writes down its colour. Okay, and then we're completing our tree diagram. Now, there are no numbers at the moment on here, but we are given enough information up in the top left on the question to fill this in. So it says 5 of the balls are blue, and that is 8 balls in the box. So 5 out of 8 for blue, leaving you with 3 out of 8 for red. And then that repeats on all of the other sections. So just make sure that all of those are correct on your diagram. If by chance you do get something wrong on here, okay, you can still get the marks in part B. The examiner will look at the numbers that you've got on your diagram and use those for the correct path. Okay, so the question says, work out the probability that Tara takes exactly 1 ball of each colour from the box. So it's not saying what colour, it's just saying 1 of each. So there's going to be more than one option here. So we're going to, if we choose blue on the first one, then we must choose red on the second one. Okay, so that's one of the paths that we could follow. Or the other path we could follow is if you choose red on the first one, and then you choose blue on the second one. Now, we're still using what we did just now, which is times in along the branches. That's still the case. But because we've got 2 options now, we're going to then be adding our second section. Okay, so let's write them out properly. So we've got 5 out of 8 for the blue, multiplied by 3 out of 8 for the red. And then that is then going to be added to 3 over 8 multiplied by 5 over 8 for the orange section at the bottom there. So multiplying your fractions, 15 out of 64, add into another 15 over 64. And remember, don't add the denominators, you're only adding the numerators. Doesn't say to simplify, so you can leave your answer as 30 over 64. Okay, right then. So if we have a look at what's been done today, we've already done the recap. So we're now going to go on to what's called conditional probability, and then we'll go on and look at some of the GCSE questions as we go through the session. So conditional probability. When you replace the item, the probabilities of the second set of branches will be exactly the same as those on the first. So that's like the example we've just been through. However, if you do not replace them, the probabilities will need to be altered to take into consideration what's happened beforehand. And if a probability has to be adjusted due to something that's already happened, that is called conditional probability. Okay, so something affects the next thing that's happening and is conditional on what has already gone on. So we're actually going to start with a worded question, and we'll come on to our tree diagrams a little bit later where we'll use what we've just gone over. So let's just have a read and pick out our key information to start. So we have, there are 12 counters in a bag. So 12 counters. 4 of them are blue and 8 are red. Find the probability of, and then we've got choosing 2 red counters when choosing at random without replacement. Okay, so in other words, they're going to take out a red counter and then not put it back before they get in the next one out. Okay, so it is going to affect what happens after it. So we're going to start to try and write this more mathematically now. As the more options we have as we go through the session, we're going to need this really. So instead of having all these words for probability of choosing 2 red counters, we can use the notation of P for probability and R for red and red. Okay, so red on the first one, red on the second one. So choosing the first red, there are 8 of them out of 12. Okay, so that fraction is still working absolutely fine for the first one. However, when we come to choose the second counter, we have already removed a red from the bag. So that means that 8 is now a 7 because one of the counters is gone. And there's no longer 12 counters in the bag, there is now 11 counters. So your second fraction has now been impacted on because of that first one. Okay, and then you're just multiplying those just like you would along the branches of your trees. So 8 multiplied by 7 is 56. And 12 multiplied by 11, 132. And we're finished. Okay. So part B, choosing 2 counters of the same colour. Okay, so it's not telling us this time that you want 2 red. It's just saying they want 2 of the same colour. So we need to think about our options on this one. So one of the options is to have both of them be in red. That would work fine, which we've already worked out in part A. But the other colour counters we have in here are blue. So the other option is that they're both blue. So we're not choosing one of each. It is saying it's 2 of the same colour. We're also saying that it's been without replacements. They're not going back in. Now, because this is part B of the question, we do not have to start from the beginning. Probability of a red and a red we have already worked out in part A. So that can just be copied down from the question above. So 56 out of 132 is your answer there. And even if you had that wrong, that follow through there would still be allowed. Okay, pick your answer up from part A, that's fine to use in part B. And then just like we do with the trees, okay, we're adding if there's more than one option. So we're going to add now to the probability of working out 2 blues. So 4 of them are blue to start with, so 4 out of 12. And if you remove the blue, that means there's now only 3 left and there's 11 in the counters in the bag there instead. So we will need to work out this probability now in order to move forward. So 56 out of 132 is still there. 4 times 3 is 12, still out of the 132 because 12 times 11 doesn't change. And then you add in your numerators, so 68 out of 132. Okay, so that question is now done. Okay, right then, another example. Again, if you won't feel you want to stop this and do it yourself before me, then please do, okay? If not, just listen to another example and you will have a chance to have a go at the next question then without me. So, a bag contains 10 marbles, of which 2 are yellow, 3 are blue, and 5 are red. Okay, so there's our key information. We've got 2 yellow, 3 blue, 5 red, and obviously we've got 10 in total. So 2 marbles are selected at random from the bag without being replaced. Calculate the probability that exactly one of the selected marbles is blue. Okay, so exactly one. So it's not saying it's the first one or the second one, it's just telling you that you want one. So if we think about what our options are, the probability is if we choose blue to start with, that means we can't choose blue on the second one. Now, to make life a little bit easier, you don't want to go down the route of saying, right, blue and a yellow, blue and a red. It's going to create too much work for yourself. So all we need to do is blue and not blue. Now, bit of, again, mathematical notation is if you see B for blue, then to turn it into not blue, you have blue dashed. Okay, so B with a little dash means not blue. So blue and not blue is one option. And then the other option is the other way around. That does count as a separate option. Okay, so you can't just accept the first one and say, well, I've done it. You have got to change it so it's the other option as well. So not blue first and then blue. So these are the 2 things that would need to be worked out here. Please don't go down. You are going to do too much work if you go into yellow and red and so on. So probability of getting a blue. So there are 3 to start out of the 10 counters in the bag to start with. And then getting not blue is everything else. So there's 7, there's 2 yellow and 5 reds, there's 7. And even though we've removed a counter already, the counter we removed was blue. So that doesn't affect that 7. However, it does affect the denominator because 1 counter has been taken out. So there's now only 9 left in the bag. So 3 over 10 multiplied by 2/9 for that one. And then for the other section, not blue first. So there's 7 that are not blue out of 10 to start with. And then to get a blue, there's 3 of them that are still blue in the bag, but there's now only 9 in there. Okay, so those are our calculations we need to do. So 21/90, add another 21/90. So your answer overall, 42/90. Okay, so can you have a go at the next one? And I will pause and come back in a second to go over that with you. So here we go. Bag contains 5 nut chocolates, 5 nuts, 6 raspberry and 10 caramel. 2 chocolates are selected without being replaced. Calculate the probability that both selected chocolates are raspberry. Okay, so both of them are raspberry. So if we write this down, I've lost my thing, there we are. So probability of R and R, we're going to use that for raspberry there. So there are 6 to start with out of 21. So if you've taken the raspberry chocolate out and maybe you've eaten it, you've enjoyed it, and then you're going on and choosing your next one, there is now only 5 left in the box out of 20 chocolates altogether. Okay, so then you're multiplying that and working it out. So 30 as your numerator, 420 as your denominator. Okay. Part B. Calculate the probability that one of the selected chocolates is a caramel chocolate. So one of them. Now this is where order is important. So because it's saying 1, probability of getting a caramel chocolate would then mean that you wouldn't choose a caramel chocolate on the next one. So C dash is how I'm going to write that. But then we do need to do that the other way round. So not caramel first and then a caramel chocolate. So caramel chocolate, there's 10 of them out of 21 to start. There were 11 that were not caramel, but it's now only 20 in there. So check your answer there. And then similar thing, but the other way around, 11/21 to begin with, and 10/20 for the caramel. And when you work through those, you'll get 110 out of 420. And the same thing on the right, giving you an overall answer then of 220/440. And again, obviously you can cancel that down, but I'm not going to do extra work that I don't need to do. Okay. So we've done the introduction. Okay, so we're going to start looking at bringing back our tree diagrams from last time and the recap at the start and looking more into our GCSE questions. So tree diagrams without replacement. A box contains 5 red discs and 3 blue discs. Okay, so let's highlight that so we can really focus in on what's going on. So we've got 5 red and 3 blue. 2 discs are taken at random without replacement. Draw a tree diagram and find. Okay, so the tree diagram isn't drawn for us here at all, so we're going to have to construct this. So the first option, the one on the left, would be the disc that you choose first. Okay, so disc 1. And if I think about what my options are for disc 1, I've got a red option and I've got a blue option. So I'm just going to put R and B onto the branches rather than writing them all out, and that would be accepted in the exam as well. Now, before I go on to the next one, I'm actually going to do the probabilities for this as well. So there are 5 red and 3 blue. So there are 5 out of 8 for red, leaving you with 3 out of 8 for blue. So that's the first part of the tree diagram done. When we move across, and we're thinking about what we can choose for disc 2 now, remember we have to follow a path. So you're going to have 2 sections coming off, one for the red and one for the blue from disc 1. My line is just lovely. Let me just rub that out. Got a lovely line going on there, and I don't know where that's come from. Okay. Again, I'm going to label them. Keep them in the same kind of order as you had already. Okay, so red and blue, red and blue. So we've got that pattern going on. Now, this really does, you have to concentrate now to work out what's gone on before. Okay, so if you're following the top path, you have already removed a red disc. So when you go and choose another red disc, there's only 4 of them left out of 7 now, so because 1 has been removed. However, when you go to choose a blue disc after already choosing a red, there's still the same number of blue discs in there that started with, so that's 3, but there's only 7 in total. And remember, if you link back to what we've done before, every section must add up to 1, so you can check it that way as well. 4 over 7, add 3 over 7, I'm happy, that's 1. Now, these are not going to repeat on the second section on the bottom right now because red had been taken out on the top section, but blue has been taken out on this one. So if you've removed the blue, okay, you're now following that path. So 3 out of 8 for the blue originally means there were still 5 red discs in there, but only 7 left in total. And if you've removed the blue already, there's now 2 out of 7. Again, check they add up to 1. They do, so I'm happy that that tree diagram is fine. Okay, so that's the first part of the question. And now we've got some probabilities to answer. So both being red would mean red on the first disc and red on the second one. So we're going to be following these top 2 paths. And just like we've done before, we always multiply along our branches. So 5 over 8 multiplied by 4 over 7 is going to give us the answer to that one. So 20 over 56. Okay. Similar thing for both being blue, but obviously we're following the bottom right-hand path now. So blue on the first one and blue on the second one. Using the fractions, it's just different fractions that we're multiplying together. So 3 multiplied by 2 is 6, 8 times 7, 56, and that one's finished. Right, when it comes to different colours, this is where you get more than one option. So that would mean that perhaps you've chosen the red on the first one, but then it would be a blue on your second one. Or in probabilities to add, you have chosen a blue on the first one and then red on your second disc. So these are our 2 options that have to be found. Okay, so following the red path first is 5 over 8. Then from that one, and you have to follow that one, don't jump down to the bottom. Okay, we're following then to blue, which is 3 over 7. For the second section, we've got blue first, so 3 over 8, multiplied by following that to red, so 5 over 7. And I'm going to run out of room a little bit here. I will put them in underneath. Okay, so 5 multiplied by 3 is 15 over the 56 that we've been using all the way along. And again, another 15 over 56 there, giving you then 30 out of 56. Okay. Probability of same colours. Now, if we use our answers from A and B, because again, there's no point in creating more work than you need to, that would mean we want probability of red and red, which we worked out in part A, probability of blue and blue, which we've worked out in part B. So I can just use those answers from above. So 20 out of 56 from part A, adding on 6 out of 56 from part B, giving me a total of 26 out of 56. Okay, and there is a checking process there, but what we've done in part C and part D is essentially every option. By having 2 different colours and then probably the same colours, if you look at your answers from part C and part D, when you add those up, you get 56 over 56. So that is 1 in total. So I've covered every option there for you to try. Okay, so you try the next one. I'll pause and give you some time and then I'll come back in and go over it. Okay, so the first part of the question says to draw a probability tree. So let's go back and read the top first now so we can check that. So we've got a bag contains 3 red counters and 2 white counters. Okay, so that is going to help us now draw this tree. And 3 counters this time are being taken. Okay, so 3 counters. Sorry, I just realised I've skipped a question, I think. I thought that's fine, we'll go with it. This one, I've taken out the wrong one, no problem. Right then, so a bag contains 3 red counters and 2 white counters. Okay, that would give you now, we're choosing 3 options. So first option, red or white. Okay, that's that one. That would be the first counter that gets removed. The second counter that gets removed then is obviously the next section across, red and white again, red and white again. But this time there's a third one. So we're going to have to do more to our tree. Okay, so we're having more sections coming off, also red and white all the way along. And then we'll have these 4 options then at the end. Okay, Right, so now we go back and look at the highlighted part. We got 3 red and 2 white. So that's 3 out of 5 in total for the first part and 2 out of 5 there. Now take care as we move across because it will depend on what's happened before. So if we're following this top path, red has gone already. So now there's only 2 out of 4 for that one. And again, 2 out of 4 for the next one because white hasn't changed, but the denominator has. Moving down to the bottom part would mean the white has been taken already. So now 3 over 4 for the top one, 1 over 4 for white. And then we've got an extra step again, and this is where it gets a little bit harder. So if we're following along the top path, we've taken a red on the first one, a red on the second one. So the reds are decreasing each time. So there's now only 1 left out of 3 counters in that bag. From the white, following this top path, we've taken a red and a red. So there are still 2 whites in there. And again, you can check those 2 do add up to 1. On the second section down, you've taken a red on the first one, but then you've taken a white on the second one. So the red is only decreased by 1. So this is now 2 out of 3, leaving you with 1 out of 3 for your white. Next one down means we followed a white and then a red. So 1 of the reds have gone already. So it's now 2 over 3 being left, 1 over 3 there. And then the final one at the bottom, 2 whites have gone already. So there's still 3 reds. And when it comes to the last one, there were only 2 white counters in there already altogether. So that must be the 0. Okay, 0 over 3 or just 0. Tend to just write 0 rather than putting that into a fraction. So a little bit more complicated tree diagram this time. And then we're going to work out part B. So it says work out the probability that 2 of the 3 counters are red. So let's have a look. Starting at the top, okay, be quite logical about the way you're following this. So 2 out of the 3. So if we're following red on the first one, red on the second one, then it must be a white for the third one. But we can get another 2 reds off this top one. So we could follow the red on the first path, then choose a white, and then choose a red. Okay, so there's 2 options coming off that first section. Or we could get 2 reds from the bottom section by choosing a white first, then a red, and then another red. Okay, so there's 3 probabilities that would need to be worked out on this question. And it's just multiplying our fractions as we go across. So 3 out of 5 multiplied by, I'm going to follow the yellow path now. So 2 over 4. Seems to be a bit of a lag with my pen here. Multiplied by 2 over 3. So that's the yellow path done. Then if we look at the next section, I'm just going to put that in highlighter so it's really obvious which section I was talking about there. Change that to yellow. Okay, so that's the yellow section. Okay, so the next one, green section. So we've got 3 over 5 for our first one, multiplied by 2 over 4 for the next one, multiplied by 2 over 3 there. Okay. And that's the green part. And then we've got one more, which is the blue section. Again, multiplying our 3 fractions. Ideally, you'd have all this on one line, but I can't fit it in on mine. Okay, but if you've got a wide piece of paper, then please put it all on one line. So 2 over 5 multiplied by 3 over 4 multiplied by 2 over 3. Okay, and that is our blue section then. Okay, so now each of those needed to be worked out. You'd have 12 over 60 for the first one. Just waiting for my pen to catch up with my brain here. So 12 out of 60 for the second one and 12 out of 60 for the third one. And when you add all of those together, 36 over 60. Okay, so we've had a look at some, obviously, tree diagrams. We've had to look at some worded questions. We're going to go back to the worded questions now, but we're going to have a look at a slightly different style of question to bring in some subtraction things going on. Okay, so start by picking out your key information in this question. We have a box contains 5 red balls and 3 yellow. 3 balls are chosen at random without replacement. Find the probability that the 3 are not all the same colour. Okay. Now, if you think about this, you could then go down the route of a red, a yellow, a red, a yellow, a red, and etc. etc. It could be a lot of workings, and if you wanted to draw a tree diagram, you could. It's whatever method you prefer, but it is only worth 3 marks. So rather than going down those different options, if we focus in on this word not and ignore that for now, if the question said, find the probability that the 3 balls were all the same colour, that would lead us to our answer quite quickly. So what we can do is do that probability, but then subtract our answer away from 1 because all probabilities add up to 1, and it would find the reverse. It would find this not all the same colour for us. Okay, so what we're going to do is have 1 take away, and it's important that you set it up properly because you do get method marks for this. So all the same colour would mean that you've got a red, and a red, or a yellow, and a yellow. Okay, so we're going to work out those two, and then we're going to subtract our answer away from 1. So this taken away from 1 is the extra part, really, from what we've done previously. So we have probability of choosing a red. Okay, so 5 of them are red out of 8 in total, but then one of those has been removed, so that goes down to 4 out of 7, and then another one removed, so 3 out of 6. And then we're adding that to all of them being yellow, so 3 to start with for the yellow out of 8, multiplied by, and we're decreasing each time, so 2 over 7 and 1 over 6. Okay, so it's set up really nicely. The examiner would be able to really clearly see what you're doing at each stage. So keep that 1 minus at the front, work out each section as you would have done before. So the left-hand one is going to come to 60 over 336, and the right-hand one is 6 over 336. Okay, you're going to add them together, so we'll have 66 over 336. Now, when you subtract from 1, this is a non-calculator question, okay? You can do it in various ways. One of the options is count up from 66 to 336 to see your gap, okay? That would be your numerator. Or some people prefer to turn this 1 into a fraction, so 336 over 336, take away 66 over 336, okay? So you can decide which process you would prefer to use there, but you do need to subtract them. So 336 take away 66 will leave you with 270. The denominators, just like when we're adding, do not change, okay, still over 336. So when you're doing a not question, you are going from ignoring the not, doing it without, and then subtracting away from 1. Okay, so question 2. A box contains 20 marbles, of which 2 are red, 3 are yellow, and 15 are black. 2 marbles are selected at random without replacement from the box. What is the probability that exactly one of the marbles is black? Okay, so pause the video, try and highlight your key information and work your way through that. I will come back in a second. Okay, so key information that hopefully you've been highlighting. 20 marbles, 2 red, 3 yellow, 15 are black. 2 marbles are then selected. Okay, probability that one of them is black. So this links back to one we did quite similar earlier on, where we are looking for black and not black. So if we think about those options, we'd have a black and then not black. So black B dash, remember, from the not, and then the other way round. So B dash, not black, and then black again. Okay. So probability of choosing a black, there are 15 of them out of 20 to begin with. And then everything else is not black, so that's 5, but your denominators are now decreased, it's gone down to 19. The right-hand one, not black to start with, would be 5 out of 20, and then to have the black on the second one, then 15 out of 19. Okay, when you multiply your fractions there, you will have 75 out of 380 on the left and 75 out of 380 on the right, giving you a total of 150 over 380. Okay, so check your answer, and obviously you can post in the question and answer at any time if you need to. Okay, on to the next one. Right then, so there are 3 red sweets, 2 purple sweets and 5 orange. Georgina takes a sweet at random, she eats a sweet, takes another sweet at random, work out the probability that both sweets are the same colour. Okay, so we've done similar things like this before, so if you pause the video, you should now be at a stage where you can confidently go on and answer this question. Okay, key information, 3 red, 2 purple, 5 orange to start with. She takes in a sweet, she eats a sweet, she then takes another. So in other words, there's 2 being taken here altogether. They're not specifically saying that, but they are in the words that they're using there. So work out the probability that both of them, again, that's another hint to say there's 2 being taken, are the same colour. So the same colour options are, we could have them both being red, or, remember, or means add in probability. Probability of them both being purple. Don't get your P's mixed up here. You could write the word probability if you prefer. And then the probability of them both being orange. So there's 3 sections to do for this question. So both red, 3 out of 10 multiplied by 2 over 9. I'm going to go a bit quicker now because you should be more confident with these. Purple, there's 2 out of 10 to start, going down to 1 over 9. And then orange, 5 over 10 to start with, going down to 4 over 9. Each section gets worked out, so 6 over 90 plus 2 over 90, add 20 over 90, giving you then, checking your answer at this stage, 28 over 90. Okay, and we'll move on. Okay, right, try this question for me and pause the video. Okay, bag contains 21 raffle tickets, 16 are white, 4 are yellow, and then 1 is purple. 2 raffle tickets are drawn at random without replacement. Calculate the probability that at least 1 white raffle ticket. Okay, so at least 1 this time. That could mean not just one of them being white, it could mean that both of them are being white. As well as that, you've also got to give your answer as a fraction in its simplest form. So they are specifically saying you have to cancel this fraction down at the end. Okay, so if a question tells you to, it means there is a mark for it. Okay, so think about your options. At least one of them is white. So let's just go with one of them being white first of all. So we could have white and not white, or we could have not white first and then white. Or because of this at least words, you could have both of them being white as well. Okay, so there were 3 options here that you needed to do. So the first one is 16 of them are white out of 21. 5 of them are not, leaving you out of 20 there. The reverse process for that one, sorry, that should be a 21 there. So 5 over 21 multiplied by 16 over 20. And then the final one, 16 over 21, but the numerator now is going to decrease because we've taken the white and we're choosing another white as well. Okay, so 15 on the top there, rather than going for the opposite options. So working through that, 80 over 420 and another 80 over 420 and then 240 over 420 there. Okay. And adding them all together, you get 400 as a numerator, 420 as your denominator. Okay, we're going to do one final question before we have a quick plenary then at the end. So this is going to be our last proper question here of our GCSE ones. So we've got 25 balls are placed in a bag. 1/5 of the balls are yellow. Let's just highlight some of this. Okay, so 25 and 1/5 are yellow. The rest are pink. Okay, so now I'm not even going to carry on reading at this stage. I'm going to work out how many yellow and how many pink I have altogether. So if you've got 25 in total and 1/5 of them are yellow, we need to find 1/5 of. Now in maths, 1/5 of the word means to times. So 1/5 multiplied by 25 means you're finding 1/5 of 25. So there's 5. For pink, obviously they're all the rest. So 25 in total. Take away your 5 that you have, leaving you with 20. Okay, so we've got 5 yellow and 20 pink. So there's an extra step in working out how many of each you had there. Okay, so let's go back and carry on reading. So we've got 2 balls are selected and they're not replaced. Ruth states the probability of selecting the 2 balls of the same colour is twice the probability that they are different colours. Okay, so same colour, twice that they are different. Is she correct? And you must show your workings. So we are going to have to work through the 2 separate options to compare our answers. So one option is that they're both the same colour. So that would be pink and pink or yellow and yellow. Okay. So the pink option is going to be 20 out of 25 multiplied by 19 out of 24. The yellow option is going to be 5 out of 25 multiplied by 4 out of 24. And when you go through all of that and work it out, you get 400 over 600 for that section. Okay. And separately to that, I'm going to start again now and work out the different colours. So that would mean I could have a pink and then a yellow, or I could have a yellow and a pink. So if we have pink first, we've got 20 out of 25. And we will have 5 because the yellows haven't changed, but the number on the denominator will decrease. And then the other way around then for the next one. So 5 out of 25 multiplied by 20 out of 24. And again, when you work through all of this, you will get an answer of 200 out of 600 there. Okay, so that if we go back and read the question said, is she correct? Now she stated that the same colour, which is my left-hand one, is twice the probability of the different colours. So we only need to look at the numerators here and think about, is 400 double 200? Yes, it is. So she is correct. And at that stage, you would be enough to just say yes, because you've shown your method and you justified it through your probabilities that you've worked out. Okay, so yes is enough there along with the 2 fractions. Don't just put yes on its own, you won't get any marks. Okay, so these are the things we've covered. So we've got one little thing left to do, and that's a matching task. Okay, so pause the video, have a go at matching the words. Now these are words that you were introduced to last week. So they are words that will come up in probability, and it's just a case of finding the right statement. So I'll come back in a second and show you those answers. Right then, so match the keywords to their meanings. Okay, so outcome, that one matched to possible results of an experiment or trial. And you've heard the word outcome as we've gone through the session today. Event, okay, that one was a set of outcomes. So again, we've used that word. Okay, we've gone through that, a set of outcomes of an experiment to which a probability is assigned. Now, fair might be one that you've perhaps come across a little bit more often. You'd probably maybe hear that word in everyday life. When something is fair, then obviously it's equal. Okay, so bottom one there, every outcome is equally likely. Biased, again, go back to that flipping of the coin, a weighted coin. If something's more like if you always land on tails, then that's biased. So that one goes straight across to the tendency that an outcome is more or less likely to occur than something else. Independent, again, is one we've heard today. So that's when one event does not affect the other, which leads then to the next one of dependent, where they do affect each other. So that one was the third from the bottom there. So when one event does affect the other, giving you then the final one, mutually exclusive. So events that cannot both occur at the same time. Okay, so thank you very much for listening. Back to you, Mr. Casey.